Welcome back to MCP Mesh, an enterprise-grade distributed service mesh designed specifically for AI agents. MCP Mesh gives you a production-ready foundation that's Kubernetes native, requires zero boilerplate, and scales from your laptop to the cloud. Let's get started. Let's begin by installing Mesh Cuddle, the command line interface that serves as your entry point into MCP Mesh. A single npm command is all it takes. npm install at MCP Mesh CLI. Now let's open Claude Code and see if it has any prior knowledge about MCP Mesh. This is a fresh session with no claude.md file, no system prompts, and no pre-configured context. We want to prove that Claude genuinely doesn't know about MCP Mesh, not because of some hidden configuration on this machine. Confirmed. Claude doesn't recognize MCP Mesh and is offering to search the web. But we have a better approach. Instead of web searches, let's teach Claude using the built-in documentation. The Mesh Cuddle Help system is your knowledge gateway to MCP Mesh. Running Mesh Cuddle Help reveals comprehensive documentation covering core design principles, architecture, key concepts, practical examples, and detailed help for every command. Watch as Claude follows these leads and rapidly masters MCP Mesh, a framework it knew nothing about just moments ago. Remarkable. Claude now has a thorough understanding of MCP Mesh. It has identified all the components, commands, and decorators, and is even offering to create an agent for us. All this from simply reading the built-in help output. No external documentation needed. Let's verify this understanding. We'll ask Claude to walk us through installing MCP Mesh. Claude returns to the documentation, confirms the required steps, and identifies the prerequisites we're missing. This is exactly the behavior we want. For local development, we need Python 3.11 or higher, a virtual environment at the project root, and the MCP Mesh SDK. Claude has found all of this in the documentation. And the best part? Mesh Cuddle provides comprehensive guidance not just for local development, but also for Docker Compose and Kubernetes deployments, supporting you throughout your entire journey. Now, let's ask Claude to fully configure MCP Mesh on this machine. Watch as it creates the virtual environment, installs the SDK, and sets up everything we need. For Docker deployments, you'd need Docker and Docker Compose. For Kubernetes, kubectl, and Helm. But for local development, this is all it takes. And just like that, we have a complete development environment for building distributed AI agents, all in under 3 minutes. Claude is eager to start creating. But first, let's verify the registry as it is the core component of MCP Mesh. The registry is up and running, ready to orchestrate our agents. For local development, MCP Mesh uses SQLite to keep things simple and dependency-free. When you deploy to Docker or Kubernetes, it automatically switches to PostgreSQL for production-grade reliability and scalability. Now let's build something useful. We'll ask Claude, can you create an agent that can give system date and time? The tools should be implemented using the mesh.tool decorator, which registers capabilities with the mesh and makes them discoverable by other agents. Every tool in the mesh can be invoked via the standard MCP JSON RPC protocol. Claude discovered how simple MCP Mesh makes agent creation. Just Python functions with decorators. The framework handles all the distributed systems complexity. Registration, discovery, health checks, and inter-agent communication are built into the runtime. The optional Mesh Cuddle scaffold command can generate starter code, but even handwritten agents are just as simple. Claude has created 3 MCP tools using the built-in scaffold command. Notice how the code is pure Python, free from the complexity typically required for distributed systems. The agent is starting. Let's see if Claude knows how to invoke these tools. Use Mesh Cuddle List to see the status of registered agents, their dependencies, health status, and more. All 3 tools are operational. The Mesh Cuddle call command provides a simple interface for invoking MCP tools, abstracting away the underlying JSON RPC protocol. During development, you can test any tool in the mesh without writing client code. Just pass parameters as JSON and get instant results. This rapid feedback loop makes debugging and iteration incredibly fast. Now for the interesting part. We'll ask Claude to create a Hello World agent that invokes the date tools internally. Watch what happens. Claude uses the scaffold command to generate the agent structure, correctly declares dependencies on the date tools, and writes code to invoke them as simple Python function calls. No networking code, no service lookups, no protocol handling, no serialization or deserialization. Just pure Python focusing entirely on business logic. The mesh handles all the distributed systems complexity behind the scenes. This is where MCP Mesh shines. Agents connect through capability and dependency declarations, not hard-coded URLs or service lookups. Our Hello World agent declares a dependency on the getDate capability. When a matching tool exists in the network, Mesh automatically injects a proxy. Simple Python code making network calls over MCP protocol. Zero boilerplate, zero complexity. Watch as the Hello World agent registers with the registry. The moment its dependencies are resolved, a proxy pointing to the date service is injected. And here's the key insight. All runtime communication flows directly between agents, not through the registry. This architecture makes MCP Mesh resilient by design, with no single point of failure. Mesh Cuddle now shows 2 agents running, both healthy, with dependencies for Hello World properly wired. For more details, run Mesh Cuddle status, which provides comprehensive information including declared capabilities, dependencies, and wiring details. Mesh Cuddle list and status make agent development and troubleshooting easy, complementing Grafana dashboards in production. Success. The greet tool invoked the date tools seamlessly. Notice that this communication happened directly between agents. It never passed through the registry. MCP Mesh uses a pull-based architecture where agents manage their own proxies. Once connected, the registry is out of the loop entirely. No runtime dependency, no single point of failure. The Mesh Cuddle list and status commands reveal all the wiring, invaluable during development and debugging. Now let's test resilience. We'll terminate the date service and see what happens when Hello World tries to call it. Here's how MCP Mesh detects failures. Agents send lightweight heartbeat requests to the registry every few seconds. The registry missed several consecutive heartbeats and marked the date service as unhealthy. Hello World learned about this topology change during its own heartbeat cycle and automatically removed the proxy, setting it to none. Notice what didn't happen. No network errors, no timeouts, no failed retries. MCP Mesh detected the unavailability, removed the proxy, and set it to none, allowing Hello World to handle the situation gracefully. Let's bring the date service back online and watch MCP Mesh restore the connection. The moment the date service resumes its heartbeats, the registry marks it healthy again. Hello World discovers this during its next heartbeat cycle and automatically rewires the proxy. No manual intervention, no restarts, no configuration changes. The mesh heals itself. And we're back. Hello World can call the date tools again, automatically rewired by the mesh. Look at Claude now. 9 minutes ago, it had never heard of MCP Mesh. Now it's orchestrating distributed agents like an expert. You can do this too. Install Mesh Cuddle, begin your MCP Mesh journey, and start solving real AI problems in the real world. Get started in seconds. Run npm install-g at MCP Mesh CLI. Then Mesh Cuddle scaffold --help to see your options. Your first agent is minutes away. MCP Mesh is fully open source under the MIT license. Check out the GitHub repo, star it if you find it useful, and join us in building the future of distributed AI agents.